Okay, guys, today we're going to talk about probability. I think you are familiar with probability, and so I think this will be kind of easy for you and something you're familiar with. But probability is the chance of an event occurring, an event occurring. And we actually, a lot of times, make a fraction out of it. The probability of an event is the number of favorable outcomes over the number of possible outcomes. And we're going to come back to that. So the likelihood that something's going to happen, or the probability, is going to range between 0, sorry, it's going to range between 0 and 1. Everything's going to be between 0 and 1. Okay, so if something is definitely not going to happen and it's impossible, we would say it has a 0 probability. That's also 0% probability. If something is certain to happen, then that means it's definitely going to happen. And so we can say its probability is 1 or 100%. If something is equally likely to happen or not happen, then we say that it has a probability of 1/2, which is also equal to 50%. So we can give probabilities as fractions, as decimals, or as percents. If you flip a coin 50 times, how many times will it land on heads? Well, theoretically, 25 out of the 50 should be heads. About half of them should be heads. And that's because when I flip the coin, there are 2 outcomes that can happen. And there's only one favorable outcome out of that. So there are 2 things that can happen when I flip a coin. It can land on heads or tails. And the probability of flipping or landing on heads, there's only one of those chances it could be heads. So we would say the probability of landing on heads is 1/2 or 50% in theory. But there's this thing called experimental probability, which would mean you actually flip the coin 50 times and you see what actually happens when you flip the coin 50 times. We call that experimental probability. Experimental probability is something that's used a whole lot in sports. If you guys are sports fans, maybe you play basketball, maybe you play baseball. Basketball, this experimental probability is a big deal when it comes to a person's free throw average. It's basically their experimental probability. How many times do they make the free throw versus how many times they try the free throw shot? So we're going to expand more on that here in the future. Okay, so again, we're looking at the number of favorable outcomes over the number of total outcomes. Okay, this is favorable over total. So let's say I give you the letters F, G, H, and I, and I tell you to randomly select a letter from these. Maybe I put them in a hat or a jar or a bag, and I tell you to randomly, random means that you're not looking, you've got your eyes closed, and I want to know the probability of selecting a vowel. This is how that will be written, okay? The probability of selecting a vowel will be written like this. The probability of selecting a vowel. Okay, so we first want to see how many things could possibly happen. 1, 2, 3, 4 possible outcomes. And then how many vowels are in that set? Well, the I guess I could have written the I like that. The I is only 1 out of those 4. So the probability would be 1/4. And we have studied these as percents. And I'm hoping you know that you already know that that's 25%. Probabilities from 0 to 1. A jar contains 1 blue marble. Let's put a blue marble in here. 3 green marbles. Let's put some green. 1, 2, 3. And 3 yellow marbles. 1, 2, 3. and 4 red marbles. 1, 2, 3. Oh, I don't know where I'm going to put that one. We'll say that one's in the jar. Okay, so we want to know, these are all going to be selected at random. It's going to be a random selection. You're not looking in the jar. I know the jar is clear, but you're not looking in the jar. And you're going to say, what's the probability of choosing a red? Well, the first thing we have to do is find the total number on the bottom. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 marbles in the jar. And how many of them are red? 1, 2, 3, 4 of them are red. What's the probability of choosing an orange? Again, there are 11 marbles in the jar. I'm going to use orange for this one. There are 11 marbles in the jar. What's the probability of choosing an orange? Well, there aren't any oranges in the jar. And so 0 out of 11 is just 0. What about the probability of choosing not an orange? There are 11 marbles in the jar. And how many of them are not orange? Well, 11 of them are not orange. So the probability there would be 1. We know consonants versus vowels. What's the probability of choosing a consonant? And we're going to write that as a fraction from these letters. If they were all put into a bag, A, B, C, D, and E, what's the probability of choosing a consonant? Well, the probability of choosing a consonant, we'd have to say, well, there's 5 letters in the bag. That's my denominator. And how many of them are consonants? 1, 2, 3 of them are consonants. E and A are vowels. We could write that as a fraction, 3/5. If I asked you to write it as a percent, I'm hoping you know that that's 60%. Can't really see that I'm writing that out there, 60%. Okay, you roll a number cube once. Find the probability that you will get a multiple of 3. Well, first of all, how many things can happen on a number cube? There are 6 different numbers that can happen. And how many of those are multiples of 3? Well, 3 is a multiple of 3, and 6 is a multiple of 3, so 2 out of 6 times. And we can simplify this to a third. All right? What's the probability of not getting a multiple of 2? Again, there are 6 things that can happen. We've got 1, 2, 3, 4, 5, 6. We want the ones that are not multiples of 2. So we don't want 2, 4, or 6. So 1, 3, and 5 are not multiples of 2. And so 3 out of 6 can be simplified to 1/2. What's the probability of rolling a 9? Well, there's 6 things that can happen on a number cube, and 9 is not one of them. So my answer to this would just be 0. I hope that helps you with probability. Now I'll give your work a try.